Okay, so today I'm going to talk to you about how we use Microsoft technologies to help us with our digital transformation. Now, I realise that not everyone's an F1 fan, so I'll talk a little bit about us as a team and the sport in general first. So, Formula One is the world's most watched annual sport. Every race has over 400 million viewers live, and over the course of an entire season, the entire audience is about 1.6 billion people. So we're one of the 10 teams that ship about 30 tonnes of equipment and a large team of people around the world to 20 different races each year to compete. As a company, we're spread across 2 sites. The one on the right-hand side there is just outside Paris, and this is where we design and manufacture the engine and all the associated systems, so the turbo, the energy recovery systems, and the exhaust. The site on the left there is in Oxfordshire, and this is where we design and manufacture everything else, so the chassis, all of the aero package that goes with the car, suspension and braking systems. Across both sites, there's a total of about 1,000 staff, and our output each year is 2 of these. So, as an IT department, everything we do should contribute towards some of the team's business success criteria. So the first one is competitive advantage. Now that sounds a bit vague, so we ask ourselves, does it make the car go faster? So it's really easy for us to work out if a project is going to provide a benefit that way. The second one is organisational efficiency, and this is to doing things like automating manual processes, removing redundant processes, improving the speed of simulations, and so on. Now, it's important to point out that organisational efficiency actually has a direct impact on competitive advantage. So the more efficient we are, the faster we can make the car go. And the third one is regulatory compliance. Now, Formula One is probably one of the most heavily regulated sports in the world. So there's an awful lot of restrictions and regulations that we have to comply with. In fact, I'll use the words regulation and restriction an awful lot in this presentation. So what's really important for us is to invent new ways that we can be competitive. So firstly, we're going to look at what we do in the area of organisational efficiency. One of the things that's really important for us in this area is that if we're going to fail, we fail fast, we learn from that, we move on. So the tool we use for this is Dynamics 365. Now, before I go into how we use it, I'll give you a little bit of background on our manufacturing process. Now, I said at the start we build 2 cars a year. That's not strictly true. We run 2 cars a year, but the car is subtly different for every single race. So the car that starts the season is very different to the one that finishes it, and it's evolving throughout the entire season. So there might be various reasons why we're going to design and make a new part for the car. This could be because it's part of the standard evolution of the car that we've mapped out from the start of the year. It could be that somebody's come up with a really good idea, an innovation that we want to try out. It could be a new project, so like a weight loss project that we want to run, or it could be due to a fault on the car at a race and we want to try and improve that part. So whatever we do, we first design a part in our CAD system. Next, what we do is we take that CAD drawing and we create a surface and we run it through CFD, Computational Fluid Dynamics. And CFD is the study of liquid and, more importantly for us, airflows over solid objects. So our CFD is run on a supercomputer. We have an 18,000 core computer running that just does simulations of airflow. Quite a lot of people ask me why this is on-premise and not in the cloud, and it's the restrictions again. So we're only allowed to use certain chipsets, we're only allowed to run a certain number of teraflops, and we have to report all this to the governing body. Once we've proven a part has worked in CFD, we'll create a model of that part, and for this we use SLA and SLS 3D printers. Now, these are really cool to look at. They consist of a large vat of a liquid, and a laser is shone onto the surface, and where the laser touches the surface, it makes a layer 1/10 of a millimetre thick. And this way, we can build a model of the part up over a period of hours and sometimes days. So we take that part that we've created, and we run it in our wind tunnel. Again, there's some restrictions here. We can only run a maximum of 35 hours a week. We can only have a maximum wind speed of 50 metres a second, and the model of the car can only be 60% of the real size car, so a lot of restrictions here. Once we've proven the part is aerodynamically efficient in the wind tunnel, we decide to we create an engineering change order, and this is the point where we actually switch to using Dynamics 365. So an engineering change order an ECO is basically a use case, and this could be a project, for example. So we're going to create a new front wing for Monaco. So by putting the ECO and the part details in Dynamics at this early stage, it means that our production manufacturing teams have visibility about work coming their way. So while the ECO's in AX, we go through a period of a design office approval process. So it's, do we have the right skills and the right machining to create this part? How does it fit on the car? Is it going to work properly? Once these parts are approved, we go through the manufacturing process. So these could be 5-axis milling machines, spark erosion, fabrication to make parts out of carbon fibre, and some parts are still manufactured by hand. So for all of the manufacturing we create a works order in Dynamics 365, and we use this to track the steps through the process. So one of these is that manufactured parts go to inspection, which is where we check that they've been built to the right size and within the tolerances that we allow. At this point in time as well, we also mark on part numbers and serial numbers. And this is especially important because certain parts of the car aren't designed to last a whole year. In fact, some parts are designed only to last a single race. So a piece of suspension, for example, might be designed to last 20 or 12,000 kilometres, and we need to make sure that we track that. So how we do this is every time the car leaves the garage, we take a note of the parts that we've put on the car and the parts that we've taken off, and this allows us to build up a history of that part over time. Inevitably, things do go wrong. So what happens in that case is that we'll feed the failure back into the design process and follow this all over again. So when things do go wrong, what we can do now is we can track the history of that component on the car back through its entire life cycle. We can see which races and tests it was run at, we can see who inspected it, we can see who manufactured it on which machine, and we can even tie the raw materials back to an original purchase order. So this gives us much greater visibility about the life of that part. So some of the benefits to us of Dynamics 365. We consider ourselves a really agile company. We generate thousands of works orders and manufacture thousands of parts every week. And Dynamics 365 really supports this process for us. It allows us to track costs for creating an individual component. So the time involved, the machining involved, the raw materials. And of course, as I said before, our production department get increased visibility of work coming their way. It has massively simplified our infrastructure as well. So we used to run AX 2012 on-premise, and it was spread across about 10 servers. And now we've managed to decommission all of those because we've got everything in the cloud. And of course, because it's in the cloud, we can access it anywhere. The integration works with the Azure Active Directory that we're using for Office 365 as well. So that's an extra bonus for us. So if somebody leaves the company and we disable their account on-premise, their account also gets disabled in Office 365 and therefore in Dynamics 365. We have learnt a few lessons. So one of the ones for us was that we were really early adopter of Dynamics 365. We were one of the first companies in the world to move over to it, and it was challenging to say the least, but we're most of the way there now. There's a few additional costs that we didn't see. And at the moment, we're not quite in the public cloud. We're still running on infrastructure as a service, but we are running the latest version of AX. And this is due to some complexities around integration with our on-premise systems that aren't cloud aware. So some additional costs that we had, we want to take our existing reports and point them to the Dynamics database. Obviously, we can't do that in software as a service. So we have a separate object stored database running in Azure that we can run our queries against. And synchronizing data between Dynamics 365 and our on-premise applications is slightly tricky, again, because it's a software as a service offering, so we can't create a VPN tunnel to our premises. So, in fact, I put down that there's an additional cost for that, but we worked out a better way to do this yesterday, so in fact, that last one can go off. But we only learnt it yesterday lunchtime, and I didn't have time to change it.
Can you tell us?
Yeah, so we're using the Azure Active Directory proxy, which enables us to send messages from Dynamics 365 to a server on our premise, which can then talk to our system. So it's a bit technical, I realise, but yeah, okay. So the next thing we use in the area of organisation efficiency is Power BI. So you can see here the way that we used to track our car build. I know people at the back can't see, but there's 73,000 lines in this spreadsheet. And we used to create this through a process of doing various data extracts, some manual manipulation. And at the time when the team of people creating this sat back and basked in the glory of their creation, it was already out of date. So what we've done now, because all this data is in Dynamics 365, is we've created our own dashboards in Power BI. And you can see straight away that this is a much better way of viewing that huge amount of data than actually seeing it in the spreadsheet. So this gives us a top-level view that the execs will be interested in, and then the users can drill down into information that they want to see based on which area of the company they work in. In some of these screenshots, I've had to blank out certain areas because I'm not allowed to tell you how much we spend on building a car each year. So that's why there's some information blurred out. So you can see straight away that it's visually much better. The users can click on areas that they're interested in and see their filtered views, or they can even click on the graph and get a snapshot of the data as it was in that time. Some of the other reports we used to use, so here SQL Server reporting services, again, quite dull to look at. And again, we've taken this data and put it into Power BI. And this is what we use to track our works order processing, so manufacturing. Again, we've got a nice dashboard. The users can do all the normal drill downs. But what we've enabled on this is the English language functionality, the Q&A functionality. And what this allows the users to do is go in and start typing queries that they want to see. And Power BI will render the results on the screen while they're doing that. We see this as a really important tool because it's a way to give the power of accessing the data back to the users. So although it's tricky to set up, it's well worth it because your BI team will actually spend less time answering queries for new static reports or new specific dashboards because the users can access the data themselves. And of course, the other great thing about Power BI that we've seen in some of the other presentations this morning is that we've also got access to this data from mobile. So wherever we are in the world, as long as we've got a data connection, we can access this data. So the benefits for us, great visualizations. I mean, that's one of the best things for me. So my development team don't spend their time creating nice looking graphs. Users having access to their data, again, giving the data back to the users in the format that they want so they don't have to come to us and ask us to do extracts or create static reports for them. And of course, you can combine lots of different data sources. So we've got one dashboard that contains data from 2 SQL Server databases and an Excel spreadsheet that we're storing in SharePoint Online. But to the users, they just see it as one set of data. Of course, being in Azure, new features are released all the time, and we can take advantage of those. And we really see this as the end of the data warehouse. So we don't have to always create a separate reporting database to point our systems up, because Power BI is able to do kind of the load and transform features that we used to do previously. Again, there are some lessons that we've learned from this. Quite important is to recruit BI specialists. They're not just, it takes a slightly different mindset to do BI successfully. And it's important for them to learn DAX, which is one of the tools that comes with Power BI. So this allows the BI specialist to import and transform data. It's a tool that you have to use in the long term, so it's better that they start using it from day one. Consider the bigger picture means don't be worried about importing too much data. If you import a small subset of data and you deliver it to the users, they're going to come back to you very quickly and ask for more. So if you can give them as much data as possible up front, it's going to save you some work in the long run. And creating a taxonomy is about making sure that you use terms that mean things to your business. So don't just use date. Make sure you qualify it, delivered date, required date, invoice date, and so on. Data quality, it's really important that your users understand the importance of data quality. Some of our old systems allow people to cut corners and not fill all the information in. And of course, that means that when it's reporting time, you don't get the data that you want to see. So it's important to impart on them that it's up to them to make sure that the right data is in there as well. And again, limiting super users, this is one of the things that we've talked about. It's great to give the power of this data to all the users, but if they're going to spend all day creating their own dashboards rather than doing their day jobs, then it might become an issue. So keep an eye on that. So if we go back to our business success criteria, the next one we're going to talk about is competitive advantage. And for this, we use Azure Machine Learning. So I'll give you a little bit of background first on the kinds of data we're talking about. So this is our car, and before it goes out on the track, we have to program the ECU, the computer on the car, to tell it how the car's going to run. While the car's going around the track, it's like an IoT device because there's over 200 sensors sending a constant stream of time series data back to our server in the garage. This server then multicasts this data around the network, and any clients that want to receive this can do, and then this data can be visualized. So the data from the car to the server is at a maximum of 2 megabits a second, and we call this telemetry data, and it includes everything that's happening on the car so the engineers can understand how the car's performing. So this could be things like what gear you're in, what speed you're going, there's suspension movement, tyre temperatures, tyre pressures. There's thousands of sets of data that we get back. Now, another consumer of this data is a VTAG, or a virtual ECU. So this is a copy of what's on the car, but we can actually run some extra analytics in there in real time. So this server generates extra channels of data, and these again are broadcast around the network. We have some other systems that we've created that consume this data to allow us to do extra real-time analysis. We do things like detecting alarm conditions on the car, so try and work out issues that could stop the car from running before they happen, so we can fix them. And also we create statistics of data or summaries of data that allows the engineers to understand how the car's performing. When the car comes back into the garage, we plug a cable in, and all the same data that was sent as telemetry is offloaded, but at a higher frequency. The maximum we can store on there is 10 megabits a second, and we then process this data through all of the systems to get a much better quality of result. Now, in the course of running 2 cars over a weekend, we generate of this data about 35 billion data points. And then, of course, you think 20 races a year plus the tests that we go to. So we're talking about a lot of data here. So there's 2 tools that our engineers at the track love. The first one is MATLAB, which is like a functional language that's used a lot in the automotive and research industry, and Excel. And as far as our users are concerned, they can do anything they want in these 2 tools within reason. So what we've done is this real-time telemetry that we have while the car's going around the track. We've taken this and we run it through a series of predefined MATLAB scripts that the users have written before the race, and then we output the results into Excel. And the good thing is with this is all that we have to worry about is pumping out the data, and then the users can create their visualizations that they want based on their role. So, for example, a race strategist is interested in different things from a performance engineer. Now, there's 4 areas of an F1 car that affect performance. So there's the driver, there's the engine, there's the chassis and the aerodynamic package, and the 4th thing is the tyres. And you'd think if you want to get the best out of your car, you'd run it at any chance that you get. Now, we can't do that. We can only run it at the races and at the tests. So what a lot of teams have done is they've built simulators, and we're no exception. So a simulator consists of a physical chassis that the driver sits in, and there's a 190-degree, 10-metre diameter screen that has projected onto it what the driver would see while they're going around the track. Now, what we've done in this area is we've taken an entire season's worth of data and we've pushed it up to Azure, and we've used it to train an experiment that works out tyre degradation for us. So because we don't actually have tyres in the simulator and they're extremely hard to simulate, whereas aerodynamics, engine performance is easy to do to a certain extent, the tyres is the thing that gives us the most problem. So with this, we can work out how best to set the car up in the simulator to run at a certain track so that the tyres don't get destroyed. What we want to do eventually with this data is to do this processing in real time and use the output to feed back into the simulator. So if the driver's driving particularly aggressively, then they're going to destroy their tyres, and it's a way of making them actually drive in a better way. So some of the benefits. Every company has big data, and we see Azure Machine Learning as a way of unlocking the potential in it that we hadn't even thought about a few years ago. Of course, it's pay as you go, so you can scale up and scale down based on what your need is, and then you don't have to actually run a cluster on your on-premises that may not be used all the time. There's a huge amount of compute capacity out there, so don't worry about there not being enough. And of course, there's a familiar tool set to any data scientists who are working on these systems, so things like Hadoop, R, and so on. And of course, as I said before, Power BI, new features are being released all the time. A few lessons that we've learned: data science, you can't just give it to someone and say, you don't look too busy, can you go and do some data science? It doesn't work that way. You have to have people who specialise in it to get the potential out of it. And they have to have an understanding of that data. What you can't do is just upload a bunch of data and hit the go button and expect things to work. You have to understand what factors influence that data, especially when you're talking about thousands of sets of data like we are. And of course, to get an understanding of the data, you need to have a certain amount of stakeholder investment. So make sure that time is put aside for that. That's all I'm going to talk about today. I hope I've given you an interesting insight into how we use Microsoft technologies.